Let's go ahead and continue on page 6 of your 6.6 notes. We were just circling the perfect cubes when the video ended. So 8 was a perfect cube, 2 to the third. Y to the ninth, 9 is divisible by 3, 6 is divisible by 3. So we bring our 2 to the 1 over. And then outside, we'll have 6 divided by 3, x squared. 8 cube root, which is 2 cubes, so 3 2's come out as a single 2. 9 divided by 3 is y to the third. And the only thing left under the radical now is cube root 3. So 2 over 1. 3 had to stay under because it didn't have 3 to get out. 6 divided by 3 came out as x squared. Cube root of 8, which remember is 2 times 2 times 2, so it comes out as a single 2. 9 divided by 3, y to the third. So now you have to think back to something you learned in chapter 5. When you're multiplying, remember how we can cancel on the diagonal? So we can cancel this way, up and down, up and down. So here we have something common, a 2. So that would leave us with a final answer of x squared cube root 3 over y cubed. So the 2 is gone. That one we don't need anymore because now this is 1. So x squared cube root 3 over just y cubed. Okay, one more on this section, and then we will switch over to a different kind of problem. So again, we have that number out in front. So like we did before, put the times sign in. So it's 3/4 times. Now I'm looking for something common. 7 and 16, nothing common except 1. X and Y, nothing common. So that's my hint to break it up into 2 separate radicals. So 4th root of 7x to the 6th. But since I'm doing 4th root, let's rewrite x to the 6th as x to the 4th and x squared. So now I have my perfect 4th and what's left over, because 6 isn't divisible by 4, 5 is not divisible by 4, 4 is, and I still have 6 x's, just now I have my perfect 4th power waiting to come out. 16, if we go over here, scoot over a little bit and down. If we go over here, 16 is 2 times 8, 2 times 4, 2 times 2. So 16 is 4 2's, so we can rewrite that as 2 to the 4th. And 8 is already divisible by 4, so we don't need to change that. So there's everything in a form ready to be broke down. So 7 has no pairs, so leave it. Not pairs, 4 of something. Quads, yes, quads. So 6 can be broke down into x to the 4th and x squared. 16 we just saw over here is 2 to the 4th, and then 8's already divisible by 4. So now we're ready to circle the things that can come out. 4 x's can come out as a single x. 4 2's can come out as a single 2. And 8 divided by 4, 8 y's come out as 2 y's. 8 divided by 4, y to the second. Okay, let's write what we have left here. So we still have that 3/4 in front times x. 4 divided by 4 is x to the first. And then under the 4th root, so we did 4 divided by 4, took that x out, then we have 7x squared underneath. Here we have 4 divided by 4 would be 2 to the first outside. So 4 2's come out as a single 2. 8 divided by 4, y squared. So 8y's come out as 2. And let's look for any canceling. No, 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 no. So that looks like that's going to be our answer. So we write it as a single fraction. So it'd be 3x to the fourth. Oh, jeepers. 3x, fourth root, 7x squared. Not x to the fourth, sorry about that. So 3x, fourth root of 7x squared, all over. And remember, in multiplication of fractions, you just go straight across, so that'd be 8y squared. So that would be our final answer, because 7 only has a single. There's only 2 x's, so those can't get out of jail. There's no radical in the denominator. There's nothing common to cancel. So that would be it. Okay, let's go ahead and go on to the next part of this lesson. Rationalizing the denominator. So what that means is we're trying to get rid of the fraction in the denominator, or excuse me, the radical in the denominator. So get rid of the radical in the denominator. And if you look at all the examples we did so far today, none of them had a radical in the denominator at the end. They all had they came out of the radical, these came out of the radical, but what if it doesn't come out? We need to know how to get rid of the radical in the denominator. You do need to know those directions. They're used on the final, they're used on the next test. They'll be used in all of your classes coming up in math. So rationalizing the denominator just means get rid of the radicals in the denominator. And we're going to learn 3 different ways to do that. So it all depends on the scenario. So this first little tidbit says, remember if you have like the square root of a squared, the 2's undo each other, or the third root of a cubed, the radical is undone by the power. So that's like saying this, fourth root of a to the fourth. These are opposites. They undo each other, so the answer is just a, or absolute value of a if they didn't tell us that they were non-negative. So 4 divided by 4, a to the first. N divided by n, a to the first. So anytime we have an index of 4, as long as we have 4 inside, that radical will cancel with that index and just the a will pop out, because 4 divided by 4 is a to the first. So we're going to use that property to help us get rid of radicals in the denominator. So here we have fourth root of x cubed. So I'm saying, okay, how many more x's do I need in order for that to pop out? Well, if I have 3 here, if I add 1 more, won't that give me 4 x's? And then 4 x's come out as a single x. So what we're doing is we're practicing on finding what's missing. What do we need to multiply that by to make it a perfect power? It's missing 1 x. So we need to multiply by the fourth root of 1 x in order for that x to pop out. Here we have 7 x's. We need 9, so how many are we missing? 2. So if we add in 9th root of x squared, then we'll have the 9th root of x to the 9th. Those two 9's cancel, or 9 divided by 9 is 1, and we get x. So when we're doing square roots, we want 2 of everything. When we're doing cube roots, we want 3 of everything. When we're doing fourth roots, we want 4 of everything. So we need to fill in what's missing. And remember, each single factor has its own exponent. So don't look at this and say, I have 2 2's and 2 x's. You do not have 2 2's and 2 x's. You have 1 2 and 2 x's. So let's rewrite that. So I say to myself, what am I missing in order for me to have that pop out? Well, I need 2 of everything, right? Since this index is 2. So I have 1 2. Don't I need 1 more? Do I need any more x's? No, I do not. Because look what happens. When I multiply these, I'm going to have 1 plus 1, 2 2's. And I already have 2 x's. And doesn't that come out as 2x? 2 divided by 2, 2 to the first. 2 divided by 2, x to the first. So I think this is what Alex wants you to type into the computer, what's missing to make it perfect. Because they give you the answer, so they just want to know the missing radicand. So that would be this. Okay, let's do one more and then I'll let you guys practice on some. Let's do C, and then you mini can practice on B and D on your own. So 5th root of 81. Well, the first thing I look at is I go, oh, whoa, 81. That can be broke down. I'm not going to add in 4 more 81s. That's just going to be a gigantic number. So 81 is 2 9s, right? Which is 4 3s. 3 3 3 3. Because 2 3s, 2 3s. So 81 is 4 3s. Are we all good with that? And you're probably thinking, why is she doing that? Well, I need to know how many I'm missing, so I have to know how many I have. So don't make it 81 to the first. We always break numbers down using the trees. So I can see I'm missing 1 3, right? And then I have 2 x's. And I have a single y. And I like to put the exponents on, then it's easier for me to see what the missing thing is. So this is what Alex is going to want you to type in. What's missing? How many more do I need? So we have 4 3s. So does everyone agree we need 1 more? Because we need 5 of everything. I'm going to try and slide my paper up a little bit under the camera. There we go. Oh, man. I just don't want to be off the... There we go. So we are missing 1 3. Now we have 5. We have 2 x's, so how many more do we need? 3 more x's. I have 1 y. How many more do I need? 4. And remember, the reason I need 5 is because 5 3's come out as a single 3. 5 x's come out as a single x. 5 y's come out as a single y. Because our goal, remember what I said rationalizing the denominator means from above? Get rid of the radical. Well, this is how you get rid of the radical, by making perfect powers of 5. So let's see what we have now. We have the 5th power of 3 to the 5th, x to the 5th, y to the 5th, which is indeed 3xy. So everything popped out of the radical because 5 divided by 5, 3 to the first. 5 divided by 5, x to the first. 5 divided by 5, y to the first. So I'm going to turn off the video now, and when I start up the next video, we'll check those two. So go ahead and do B and D now, and then we'll check them on the next video.